Hi there, my name is Mark and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array and how it impacts my power costs. This video details my results for April of 2025, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. Here is a picture of the Sense device that measures my power usage and solar energy generation. It is located inside my electrical panel and clamps sensors onto the wires. As you can see from the monthly summary statistics, a total of 2,167 kilowatt-hours of electricity were generated by my solar system in April of 2025. The total generation was about 10% more than April of 2024. Here is a picture of our 16 kilowatt ground mount solar array. The solar array is directly south-facing in one of our pastures with no trees or other obstructions around it. We have 50 ZN shine panels, rated for 320 watts each, with Hoymiles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240-volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed, no time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using the Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. Here is a day-by-day chart showing the total number of kilowatt-hours of solar production and house usage. Spring months is where you start seeing the higher daily solar production values. The highest solar production day was April 17th, with a total of 106.8 kilowatt-hours generated by the system. There were 13.7 hours of sunlight that day. Here is a graph of the solar generation and usage, sampled once per minute on the peak solar generation day of the month. Somewhat inconsistent solar generation due to clouds coming and going during the day. Since a total of 106.8 kilowatt-hours of energy were generated for the day, this means an average of 7.8 kilowatt-hours of generation for every daylight hour. This graph shows the per-day net difference between the amount of energy sent to the grid minus the amount of energy received from the grid. Negative values on the y-axis mean that more energy was pulled from the grid than was sent to the grid. 0 on the y-axis means they were equal for the day. Positive values on the y-axis mean that more energy was sent to the grid than was pulled from the grid on that day. Net value was negative for only 6 days of the month as compared with the more than 20 for March. This chart shows the low and high temperature on the farm for each day in April. The low of 30 degrees Fahrenheit, -2 Celsius, was a little cold for this time of year. The high temperature of 76 degrees Fahrenheit, 24 Celsius, was higher than is typical for April. Here's a yearly comparison of solar production, comparing by month, along with a cumulative total for the year. April's higher than typical solar generation brings us up to the highest cumulative total for the year for any year since I installed the system. Here's a yearly comparison of energy usage, by month of the year. 2025 is the second lowest cumulative usage since the system was installed. I am getting very good at optimizing energy usage. Here's a graph showing the actual amount of money I paid to the power company for each month from 2022 through 2025. The $7.49 bill is for the standing charge to have a power meter, even if no net billable amount of electricity is used. The bills in 2023 for the first few months were relatively high because I made some adjustments in electric furnace usage that were causing higher bills. Looking at the remaining credits from my power company, the March 2025 bill was also this minimum charge, based on the remaining credits I have. The utility resets the credits on March 31st each year, so they don't carry over from year to year. Because April was higher generation than usual, my power credits are starting to build up. Here are a few snapshots from the high power users in my house for the month. For April, the hot water heater, not the electric furnace, was the highest electricity user at 158 kilowatt-hours of electricity for the month. The hot water heater and furnace together comprised about 22% of the total energy usage for the month. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video. If you have any other statistics that you would like to see, please leave a comment down below. Have a great solar day and see you next month.